Question number 11. So I've weighed out some solute. Solute is just a general term for something that dissolves in something. So the solutes start off with, after the weighing bottle is 4.48, that's the mass of the bottle, that's the mass of the bottle plus the solute, the solid that you're dissolving in the liquid. So if I subtract the two, then I'll find out the mass of the solute. Once I've found the mass of the solute, I need to work out the uncertainty. Now I've got two readings. I've got a reading of a mass with the solute, and then I've got another reading of just the bottle on its own afterwards, after I've added the solute, poured the solute from the bottle. So I've got two readings. Each reading, read this carefully, each reading from the balance has an uncertainty of 0.005, but I've read from the balance twice. So I've got that uncertainty the first time I've read, and that uncertainty the second time I've read, so my uncertainty is twice. Let's have a look at that solution. The mass used 10.13, take away 4.48, 5.65 grams I've added. The balance each time it's used has got an uncertainty of 0.005, and I'm doing two readings on the balance, so I've got to multiply that by 2. So the total uncertainty is 0.005 times 2, which is 0.01. The uncertainty is the small number divided by the big number, 0.01 divided by 5.65 multiplied by 100%, 0.18. The answer is C. Which of these is going to produce this spectrum? Now let's go through. We've got a data book alongside us, but let's see if we can do it without the data book. Ethanol. Ethanol has got an OH, and OH produces a broad, large absorption here, around about 3,500, and that's not there. So it's not ethanol, because the OH, the alcohol, would produce a broad, wide absorption around about 3,500. Propanoic acid has also got an OH, and its OH is also wide and broad, sort of here around about the 3,000 mark, 2,500 to 3,000, somewhere here, and that's not present, that's not broad and wide. So anything with an OH, an alcohol, or an oic acid, an OH is a broad, wide absorption, so it's not B and it's not D. Pent-2-ene, the carbon-to-carbon double bond, is going to be quite hard to spot. Butanone, the carbon-to-oxygen double bond, is here. That's that one at around about 1,700. Let's have a look at the data book. Butanone, carbon-to-oxygen, is present 1,680 to 1,750. That's that one, as we've said. So we've identified a carbon to oxygen double bond. Ethanol hasn't got a carbon to oxygen double bond and hasn't got the broad, large absorption that's at 3,230 to 3,550. Pentanene is a carbon to carbon double bond. That should be at 1,620 to 1,680, around about here. Sometimes quite difficult to spot around about here, but we know it's not pent-2-ene anyway, because we've identified this carbon to oxygen double bond, which is a really strong peak, absorption peak here at 1,680 to 1,750, and propanoic acid OH would be a broad, large absorption here around about 3,000, 2,500 to 3,000, so it's definitely butanone.